Hi viewers, welcome to HS Learning channel. So today we are going to discuss about some important formulas in this state space model or state space analysis. Okay, so first we are going to discuss about this state transition matrix. States transition formula is given by phi of t is equals to e power at. This is nothing but this is e power at. This is nothing but Laplace inverse of Si minus a whole inverse. Okay. See, if the given A matrix, if it is a 2 by 2 matrix like this, okay. So actually this Si minus a whole inverse formula is cofactor of Si minus a whole transpose by determinant of Si minus a. This is the basic formula. But according to this matrix size, if it is a 2 by 2 matrix, then the determinant formula 2 by 2 means you have to take A, B, C, D. So determinant formula is AD minus BC. And cofactor of Si minus a whole transpose for 2 by 2 matrix, what you have to write is, see, for this ABCD, just interchange these two, means you should write this term here and A here, and just assign minus signs for this minus B and minus C. So then at last the formula becomes, so your formula becomes like this. Your formula is Si minus a whole inverse is equals to D minus B minus C A. Okay. In front of it 1 divided by what is this determinant? AD minus BC. This is the formula for 2 by 2 matrix. But when your A matrix, given A matrix is a 3 by 3 matrix, then what is the formula? Formula is same. Si minus A inverse is cofactor of Si minus A divided by whole transpose divided by determinant of Si minus A. But see how to calculate the formula of determinant for 3 by 3 matrix means first write one here, first value. Okay. So then you have to consider these two. If you are taking this value as plus 1 and this minus and this plus. Okay. So you don't consider this row and this column. Minus 2 into 9 minus of minus 3 into 4 means it becomes plus. Next minus 1. Okay. Whatever the value is here, you just write that value here. Here all my values are 1. That's why I wrote here 1. Whatever the value is there here, suppose if it is 2, then you should write here minus 2. Plus, minus, plus. But whatever the value is here, that you should write for determinant. And second minus 1. This row and this column you leave it. Okay. So minus 1 into 9. 9 into minus 1 is minus 9. Minus of minus 3 into 1 is plus 3. Okay. So that's why I got minus 9 plus 3. That means I wrote here 9 into minus 1 minus of minus 3 into 1. When you are considering this, this column and this row you leave and write minus 1 9 minus of minus 3 into 1. So in the same manner you calculate this for plus. This and this you leave it and you take minus 1 into 4 minus of minus 2 into 1. So it becomes plus 2. So you calculate like this. 9 2s are 18, 4 3s are 12, and all the calculations you do, you are going to get minus 2. This is the determinant for 3 by 3 matrix. And if you consider the cofactor of this, cofactor of A transpose, you should determine here. This is A matrix. So how to determine cofactor means, see, here whatever the value is here, minus 2, minus 3, 4, 9, here whatever, it may be 2, 3, 1 like that. But for finding the cofactor, should not consider all these values. Okay. See how what I am trying to explain is, it's like, see, it's like plus, minus, plus, minus, plus, minus. Next plus, minus, plus. See here first you should consider plus 1. So we are considering this. So this row and this column you leave it and you take -2, -3, 4, 9. And again -1 you mention whatever the value here. Don't consider that value. You should mention it as -1. So -1. So column, row. So you are remaining with -1, -3, 1 and then 9. Okay. Some mistake I wrote here. It is 1. This is -3 and 1 plus 9. Okay. So again this is +1. So leave this column and this row and you write it as -1, -2, 1 and 4. And coming to again this becomes -1. Okay. Whatever the sign is here, you don't consider the sign as well as value. You should write +1, -1, +1. -1, +1, -1. But when you are considering this -1, so this you are considering means this row, this row and this column you leave it and you are going to write 1, 1, 4, 9 and this +1. So you remove this row and this column and you should write it as 1, 1, 1, 9. Again this minus. So remove this row and this column and you are remaining with 1, 1, 1, 4. Okay. So for this +1. So row and column you are remaining 1, 1, -2, -3 and this as -1. So -1 means row and column if you remove 1, 1, -1, -3 and this is +1 you consider. One row and one column 1, 1, -1 and -2. -2. Okay. So means you are writing like this means here you have to cross multiply. AD minus BC you have to do. 9 into 2 -18. -18 this is -3. Minus of -3 into 4. So -18 plus 12. So you are going to get -6. Again -9. 9 into -1 -9 minus of -3 into 1. So again you should write it as -1 into 9 minus of -3 into 1. Already you are going to have one minus sign here. Again you should apply AD minus BC formula here. Okay. So it becomes -9 plus 3 is -6 and you have one minus sign. So it becomes +6. Again you apply here AD minus BC. Okay. -1 into 4 plus 2. So -2. So you are going to write -2 here. Okay. So AD minus BC here also 9 into 1 minus 4 into 1. 9 minus 4 is 5 minus sign. So you are going to get -5. So you should apply AD minus BC formula all over here. Then you are going to get this matrix. Then transpose. If you transpose this, change rows into columns and columns into rows. Then whatever the matrix is, rows means total this is a column. Now this becomes a row. 6 minus 5 minus 1. 6, 8, 2. Then -2, -3, -1. So now this is the cofactor of A transpose. Okay. So this and the denominator you should write if you want to calculate this A inverse. If you want to calculate A inverse, okay, you should write like total this matrix into 1 divided by what is the determinant is -2. Okay, -2. That means you should multiply each term -6 by -2, -5 by -2, -1 by -2, 6 by -2, 8 by -2 like that you should write. Okay. This is the just basics of this SI minus A whole inverse. If you are given 2 by 2 matrix or 3 by 3 matrix, then how to determine this SI minus A whole inverse. In the exam he will give A matrix. Okay. And this I is the unity matrix or identity matrix. If it is 2 by 2, you should write 1, 0, 0, 1. Okay. Next, again, some important formulae. State space model representation by using the canonical form. This canonical form, it is also called as the diagonal form. So the formula for this is x dot is m inverse am into x plus m inverse b into u, and y is equals to cm into x plus du. But before remembering this, you should know this formula. That is state space model or state model representation. So if in the question they will ask like determine the state space model or state model representation of so and so matrix and differential equation, like this they will ask. So then you have to determine state space model, means you have to determine both state equation as well as the output equation. State equation is given by x dot is equals to ax plus bu, and output equation y is equals to cx plus du. From these equations you are going to get this equation. That is, this is just state space model, but this is state space model by using the canonical form. So that you observe the formulas. By using the canonical form, what is the formula, and just what is the state space model representation, this is the formula. See, in this to determine this formulas, to state equation and output equation to write in this form, so different methods they will ask. See, first method what they will give is, they will give some differential equation. So if they give the differential equations, you should modify it and calculate it, and you should get the matrix form. Okay. So see here the differential equation what he gave: y 3 dots plus 3 y 2 dots plus y dot plus 9y is equals to 10. Okay. See this equation, state model equation, x dot is equals to ax plus bu. It is nothing but x1 dot x2 dot is equals to, okay, so and so values like a11, a12, okay, a21, a22 into x1 x2 into x1 x2 plus u1 u2, okay, into b, like that. Okay. So or else you are going to get b matrix. B matrix say like b1, b2 and then u. Okay. You are going to get u. That means x dot is equals to ax plus bu. And see, he gave the differential equation here. Remember how many dots here? 3 dots. That is n is 3. How many dots here? That is the n number. 3 dots means n is 3. So you are going to have 3 variables, that is x1, x2 and x3. So first consider y is equals to x1 as usual. Then y dot is equals to x1 dot. You name it as x2. Again you double dot. Y double dot means x1 double dot, x2 dot, that is x3. And see, what do you mean by this dot means, it is nothing but y triple dot is nothing but d cube y by dt cube. Okay. So now see here, y double dot means d square y by dt square is equals to d square x1 by dt square is equals to dx2 by dt is equals to x3. Or else y double dot is equals to x1 2 dots equals to x2 dot equals to x3. Again if you 3 dots, x1 3 dots, x2 2 dots and x3 1 dot. Okay. So see here our equation, state equation, how it should be: x dot equals to ax plus bu, that is x1 dot x2 dot is equals to, right? So means on the left side you should get the equation in terms of x1 dot x2 dot. Here we have 3 variables. So our equation should be dragged in the terms of x1 dot x2 dot as well as x3 dot. Okay. So we have x1 dot here from this. What is x1 dot? X2. In terms of x1 x2. See, x1 dot, x2 dot, x3 dot should be in terms of right hand side. What should be in terms of x1, x2 and x3. See here for x1 dot, x1, x2, x3 in terms of it is in only x2. And coming to x2 dot, it is in terms of x3. Why I am taking only x1 dot, x2 dot? Our equation is only for x1 dot, x2 dot and it should be in terms of x1 and x2. Okay. So now we don't have x3 dot. See, x3 dot is not in terms of any x1, x2. It is having all dots, not in this format. So that's why you substitute in this equation. Where? In this equation. See, y triple dot is x3 dot. So x3 dot plus, now y double dot means you have x1 double dot, x2 dot, x3. Which to substitute? We should substitute x3. Why? Because we want x3 dot in terms of x1, x2, x3. Right? So that's why here when you are substituting in place of y double dot, you substitute the term without the dot. So without dot, which is the term for y double dot? X3. So x3. And y dot if you consider, you have both x1 dot and x2 dot. What I told, you should consider the term without the dot. Dot means it is a differential equation. Don't consider. So you consider only the normal term, that is x2 plus 9y. Y what we assumed? x1 is equals to 10u. So now you mention in terms of x3 dot. Okay. Minus 9x1 minus 5x2 minus 3x3 plus 10u. So now you represent in terms of matrix. x1 dot, x2 dot, x3 dot. In x1 dot, is there any x1 term? No. That's why 0. x2 term? Yes, 1. x3 term? No, 0. Next in x2 dot, you have no x1 term, no x2 term. Only x3 term is there. And in x3 dot, you have x1 term, x2 term, x3 term, and as well as x3 term is there. So now you complete the matrix. Here it has x1, x2, x3 plus bu. So bu, u only. See, in x1 dot, do you have any term with u? No, 0. x2 dot, any term with u? No, 0. And x3 dot, you have any term with u? Yes, there is 10. So you write 10. Next again you should write y matrix. Y is equals to, see, only one term is there, that is x1. Only x1. Y. We don't have here y1, y2, y3. We have only one y. So that's why y is equals to x1, x2, x3. Only x1 is there 1 and x2 and x3 are 0. So represent it with x1, x2 and x3. This is one method of problem. Another method, he will ask the question like determine the state model by giving the transfer function. If he gives the transfer function, see here, this transfer function you can write cross multiply and you can write y of s into s square plus 5s plus 6 is equals to, like this you can write y of s into s square plus 5s plus 6 is equals to u of s into 2s plus 3 you can write. But here for u of s you are having two terms, s term and 3. So to replace this s term you are going to write it as u dot. So that is not possible in our calculations. If the problem was 3 divided by s square plus 5s plus 6, then u of s into 3, like that you can write. And as usual you can take the inverse Laplace transform and you can change it into the terms in the same differential manner. Y double dot, okay, 5 2 dots plus 6, like that you can write. But here it is given 2s plus 6, 2s plus 3. So to solve this, see, let us assume this s square is equals to x2 dot. So anyway, s power 1 will be x1 dot is equals to x2. Reverse process. See, x2 if you assume s power 1, then x2 dot is equals to s square, double differentiation. And you assume x1 is equals to 1. Okay. Inverse Laplace transform I am going here. So replace the u of s is s square plus 5s plus 6. So u is equals to s square is x2 dot and s is x1 dot, that is nothing but x2 plus 6 x1. So you are going to get x2 term from here, x2 dot. So x2 dot is minus 6 x1 minus 5 x2 plus u. Okay. See, reverse we are going, x2 x1 is 1 means x1 dot it becomes s power 1, that I assumed as x2. And again if s2 dot if you do, you are going to get s square, right? So here you write the matrix, you have x1 dot is x2 So here x1 term is 0 for x1 dot, x2 is 1, and for x2 dot x1 x2, so x1 x2 plus bu means for x1 dot no u term 0, so x2 dot you have one u term 1, so u, and as usual y is nothing but what we took here, y is nothing but, see here y of s is 2s plus 3, right? So y what becomes, y is equals to what is s, x2, so 2x2 plus 3 into 1, 3 into 1 means 3x1, so I wrote here y is equals to x1 x2, 3 in 3 2 x1 x2. Okay, this is one method, and another is solution of state model. So until now we seen two formulas, and now again another formula, solution to the state model. So solution to the state model, you are going to have homogeneous and non-homogeneous. Homogeneous means x of s is equals to x naught into si minus a whole inverse. Okay, so if you want in terms of t, so x of t is equals to Laplace inverse of si minus a whole inverse into x of 0. Non-homogeneous means you are going to have x of s is equals to x of 0 into si minus a whole inverse plus b into si minus a whole inverse into u of s. So in the exams, they will ask the question like determine the zero impulse response, zero state response. This is nothing but the non-homogeneous equation you have to determine. Okay, zero impulse response is x of 0 into si minus a, and anyway we learned that e power at is equals to Laplace inverse of si minus a whole inverse. Okay, so if you write it here same way, x of t, then it becomes L inverse of si minus a whole inverse, that is nothing but e power at. See what I wrote here. Laplace inverse of si minus a whole inverse is nothing but e power at into x naught. Okay, so this b into si minus a into u of s is the zero state response. The point here to remember is that if in the question he asks obtain complete time response for unit step input of the system, if the question is like this, then you have to determine complete time response means this is the complete time response, that is you are going to do the non-homogeneous system. Okay, and what he asked, unit step input, so whatever he is asked here, that you should replace in place of u of s. So as he asked unit step, you should replace in place of u of s 1 by s. This term won't change. This term won't change for any inputs. Okay, whatever this is the zero impulse response. So right, so that's why it will not have effect of this. But whenever he asks this unit step input, then you should determine non-homogeneous equation and replace this u of s with 1 by s. And another formula is transfer function of a matrix. It is given by c into si minus a whole inverse into b plus t. Anyway, he is going to give the matrix in the exam like x1 dot x2 dot is equals to, okay, so on, so matrix 1 2 3 4 into x1 x2 plus 0 1 into u. Okay, so if the matrix is given like this, then you know this is a, x dot is equals to ax plus bu. So this is a matrix and this is b matrix, and the matrix y is equals to 1 0 into x1 x2 plus nothing is given means it is 0, d is 0, du, y is equals to cx plus du. So here you have C matrix. If the D matrix is not given, you assume it as 0. This becomes 0 and you have to determine C into Si minus a whole inverse into B, right? And already we seen this formula, Si minus a whole inverse for 2 by 2 matrix, 3 by 3 matrix, right? Next, properties of state transition matrix. So a state transition matrix is given by phi of t is equals t power at equals to L inverse Si minus a whole inverse. Phi of 0 is e power a into 0 is I. Phi inverse of t is phi of minus t. 5 power k of t is 5 of kt, and 5 of t1 plus t2 equal to 5 of t1 into 5 of t2, and 5 of t2 minus t1 into 5 of t1 minus t0 equals 5 of t2 minus t1. If you ask to prove this, then you simply substitute in place of here, in place of t. See here 5 of t1 plus t2 he asked. So in place of e power, okay, a into phi 1 plus phi 2. That means e power a into phi 1 into e power phi 2. Then it becomes phi of t1 into phi of t2. Easily you can prove. And in next video, okay, we shall see another simple topic. Thank you.